This is tutorial question 3. A rectangular gate that is 2 meters wide is located in the vertical wall of a tank containing water as shown below. It is desired to have the gate open automatically when the depth of water above the top of the gate reach 10 meters. At what distance d should the frictionless horizontal shaft be located, and what is the magnitude of the force on the gate when it's open? So we have a situation like this, and then the D here is the distance from this point to the shaft. So the question of A here, we need to calculate what is the distance of D where the shaft is in frictionless condition. So for question A, frictionless condition occur when moment is zero. Force cannot be zero because water exists. The only way to make it zero is by having a zero distance, means frictionless occur when the resultant force acts on the hinge. So according to this idea, we assume that we need to put a hinge at where the resultant force occur from the water to the wall here. So the calculation will become like this. We could calculate the location of YR by using this equation. So this is the moment of inertia, where it is 1 over 12 AB cubed like this. So and then we could get the value of YR is equal 12.11 meter. So and then because we know that the distance here is 10 meter given in the question, so we could calculate the value of D here as YR minus 10, which is D is equal to 2.11 meter. And then we need to calculate the force. So we use the equation of Fr equal to rho G, H, C, and A. So we substitute all the value. We know the HC here is 4 over 2 plus 10. So please be careful because we have a submerged area here and the water level is above the area. So we need to we note this is the centroid, and we need to determine the distance from the free surface to the centroid here. So it is 10 meter plus the gate height here divided by 2. So we get as a 4 over 2 plus 10, and then we multiply with the area, which is 8. So we get it is 941.8 kilonewton. So we found that the minimum forces required to open the gate is 941.8 kilonewton.